Welcome to another exciting educational video brought to you by Upvision Concept Academy. So in today's lesson, we'll be looking at IGCSE physics, and the topic again for the discussion is SI units, significant figures, standard form, and unit prefix. So if you're new to our channel, kindly subscribe to the channel to get more videos. Also share with your friends so that they can have access to our videos. So sit tight as we go through the objective. The first we're going to be looking at under this topic is to recognize the use of correct SI units for physics quantity. Secondly, to convert between different SI units. Different SI units, okay? Different units, I beg your pardon. Different units, okay? E.g. from cm to meter, from gram to kilogram. Thirdly, to write very large and very small numbers in standard form. And fourthly, to use prefix, unit prefix, like milli, micro, and kilo correctly. Then finally, not on the board, round numbers sensibly using the correct significant figures. Okay, so sit tight. Now we'll talk about conceptual explanation. Physics is largely a language of measurement. Okay, so we actually use it to communicate clearly. Every scientist in the world uses the same unit, and it's called System International. System International. So SI units is known as System International. Okay, so this unit is uniform. So if I measure something in Nigeria, for instance, in Canada, it's still the same measurement is going to give me. Why? Because I'm using a standard and it is international. So we'll go into the 7 SI base units. The first I have is the length. The length is a basic unit, SI unit. So the symbol for length is L. Anytime you see L in physics, you know I'm talking about length. And the SI unit is in meters. Okay, they have other units, but the meter is the standard unit that we are using. Okay, you have other units for length. You have centimeters, you have milliliters, you have kilometers, and so on. But the meter is the standard that we're using. That's why sometimes when you're doing calculation, you have to convert wherever you are, whether you are in cm, or you are in millimeter, or you are in kilometer, you have to bring it back to meter for your calculation. So that is why we have meter as the SI standard unit for the length. So the next, the symbol is M, small m, letter M. Okay, so that's for the length. So another quantity I'm looking at here is the mass. The mass. The mass is, the symbol for mass is M. Again, symbol is M. So when I say symbol, different from unit, symbol actually means like how is it represented in calculations. I'm writing out calculation, formulas, for instance. This is what I'm using to represent these quantities in formulas. So M is mass in formula, but in the SI unit is kilometers. Sorry, kilogram. That is the SI unit for mass. Other units under mass, you can have gram, you can have milligram, you can have tons. You understand? Fundamentally, you used to go and know how these things work, how the conversation is. 10 milligram make 1 centigram, 10 centigram make 1 decigram, 10 decigram make 1 gram, 1,000 gram make 1 kilogram, and 1,000 kilogram make 1 ton. But out of all these units under mass, the SI unit is kilogram. So wherever you are in mass, if you are in milligram, if you are in centigram, if you are in decigram, just convert what you have as the value given for your calculation into kilogram if you are to consider it in SI unit form. Okay, so physics is actually a progressive knowledge. In your sciences, basic sciences, elementary sciences, in your lower school grades, you have been taught how to convert from these different measurements under mass. Okay, so the unit is kg. is kg. Okay, so number 3, quantity is time. Time. In formulas, is represented with t, small t. Anytime you see small t inside a formula, you know you are talking about time. And the SI unit is in seconds. Though you have other units, you have minutes, you have hour, but you have milliseconds. But wherever you are, again, I say again, wherever you are, what quantity you are being given as units in your calculation, convert it to seconds before you can use it. Okay, so under unit symbol is S, second unit symbol. Okay, now again, this unit symbol is when you want to write it in quantitative manner. This is what follows the number, the numerical. For example, if I want to say 10 meter, I'll come here, I'll say 10 meter. If I want to say 10 kilometer, I'll come here and say 10 kilometer. If I want to say 10 seconds, I'll come here and say 10 seconds. See, this is what is accompanying the quantitative value. Okay, so this is very important as well in physics. Okay, I'll take this off. Now, the fourth one, fundamental quantity measuring is electric units, electric current, electric current, electric current. Okay, so electric current symbol is I, capital I for current, and the unit for SI unit is ampere, and the symbol is A. So I can have 10A, meaning 10 ampere. Okay, so the next one, number 5, is temperature. Temperature is the degree of hotness or coldness of a body. Okay, temperature. And the unit, the symbol is T, capital T. The unit, SI unit is in Kelvin. And the unit symbol is K. So I have 10K. 10K is 10 Kelvin. The second to the last, I have amount of substance, amount of substance, amount of substance. Okay, so the symbol is N, lower N. I have the SI unit as mole. Then I have the unit symbol as MOL. And finally, I have luminous intensity. I hope you can see this, yes. Luminous intensity. Intensity. Okay, so this is I subscript V. I subscript V. So I subscript V, and the SI unit is candela, and the unit symbol is CD. Okay, so CD. So 10 CD is 10 candela. Okay, so so all other units, all other quantities, like speed, like force, energy, are derived units. So what does that? That means that they are derived from combination of either of these. Force, speed, energy, etc. They are derived from this. So we need to build this from the base. I'm going to be giving you some also derived units, quantities. I beg your pardon. This is the fundamental quantities. Like I said, they are fundamental. They are fundamental. 6 and 7. There are 7 of them. They are fundamental. So, but the common derived units, quantities and their units, will come up in the next discussion. So I'm going to analyze 5 derived quantities on the board. The first derived quantity I want to talk about is speed. Speed is derived from 2 quantities, fundamental quantities, is derived from distance and time. So the formula speed is V is equals to D over T. Distance over time. Distance is length, and time is also a fundamental quantity. So both length and time are fundamental quantities, just as we have seen. The SI unit is the combination of the 2 of them, M and S. See, M/S means that M is the numerator, that is length, and this is the quotient operator, that's division, and S under is the time. So this is the unit, SI unit for speed. So the next one, the symbol, unit symbol is like this, ms raised to power minus 1. So this is how you put it, meter per second, meter per second, meter per second. So this is how you write it in a linear form. Okay, so the next quantity, derived quantity I want to discuss is the force. Force. Force is F, the combination of mass and acceleration. Mass and acceleration. Actually, acceleration itself is not a fundamental quantity, but acceleration also came from velocity and time. Okay, so it's a long haul. It's a long haul. Let me break it down. Mass is a fundamental quantity. We know that. But acceleration is actually the change in velocity over time. Okay, so this is fundamental, this is fundamental, but velocity is not fundamental as well. But recall that velocity, or the change in it, is actually the change in distance by change in time. So you see that m times, if I have this, I have it as length is distance over time, then times time itself. So I have L, that's m times L, then this one is t raised to power minus 2. So this, all the values here, all the quantities here, the parameters here, m, l, t, they are all fundamental quantities. You understand? So this is how force is expressed in fundamental quantity, in fundamental quantities. But this is the formula. So let me take this off. I just want to show you that even the breakdown, by the time you break down mass and acceleration, this is what you are going to get. Okay, so let me take this off. Okay, so F is equals to MA, and the unit, SI unit is Newton. Newton is N, like this. And the units in base units is kilogram meter second square. So these ones are all fundamental quantities. So the third derived quantity I want to talk about is energy. Energy is defined as the rate of work done. So energy is E is equals to force times distance. Again, force is a derived quantity, but distance is a fundamental quantity. Force can be broken into derived components. I just did that in this place. Can they broke that into derived components? And the units, SI units, is in joule. Is in joule, while the joule is J, like this. So while the unit in base unit is kilogram per meter square per square meter. Kilogram meter square per square per second square per second square. So kilogram meter square per second square. Okay, so the fourth one is power. Power is another derived unit, and power is defined as the rate of work done. The rate of work done, rate is energy per time. Energy per time. So it is, the unit is in watts. Watts, SI unit is in watts. Like I said, you can also have other units for watts, kilowatts, megawatts, milliwatts, and so on. But when you are doing your calculations, find your way to watts. Okay, and the units in base units is the same thing as energy, kilogram meter square per second square. All right, so the fifth one and the last for this discussion under derived quantities is pressure. Pressure. Pressure is force per unit area. So pressure P is equals to force per unit area. Sometimes when you're writing out your exams, you do well to define what your parameters are. So if I say define pressure and you say pressure is equals to force divided by acceleration, by area. You see, I'm calling acceleration for A. So if I say P is equals to F over A, I will now come and say where. Always do that in physics. It's very polite. it shows that you know what you are doing. Where P is equals to pressure, you understand? Where an F is equals to force, always define what you are using. And A is equals to area. So define it. It makes the examiner's work easy to follow what you are doing. Mind you, we're not here to mark you down. We're here to see how, but there are standards actually. If you don't follow the standards, you will be marked down. So, but as we progress together as a teacher and learner relationship, I will walk you through how you do things like this. So for pressure, the units, SI unit is Pascal. Pascal, PA, Pascal, and the units in base unit is kilogram per meter per second square. Kilogram per meter per second square. No, not per second square. This S now is distance. As different from this. This one is saying time. This S is distance. So kilogram per meter per. Sorry, I was right. Kilogram per meter per second square. Yes. Okay. So we'll go on to the next one. Okay, so now we'll go into why standard form and prefixes. Why do we have to use standard form? Standard form is a mathematical expression of numbers, some kind of numbers. So we express it in a form. So and they call standard form. And prefix is just like letters that comes before the SI units. Where you have kilo, milli, ampere, mega, and so on. That's prefix. So, but for standard form, instead of writing large numbers or very small numbers, for instance, if I have a number like this, 0.00000012 meters. If I have something like this, instead of writing it like this all the time, I will convert it to standard form, and I will say it is 1.2 times 10 to the power minus. Now, whatever I'm going to put here as the exponent will come from the number of the number of times I have moved this position, this decimal position, to this point. This is my start point, and this is my destination here. Understand? So if I move it 1, 2, 3, 4, 5, 6, 7, that's to the right. I've counted 7 steps, moving this decimal point to where this first number is. That is first significant number or figure is. So that's how I have it at 7, n. So you understand what I did here? I'll give us another example. I have 300000000 dot. Okay, let me not put the dot, but assume that when you have a number like this, you always have a dot at the end. Now this dot here is this decimal point, so I'm moving it from the right to the left. So it's going to be positive. So I'm going like this, it's going to be positive. So I'll move this point to where this point is. 1, 2, 3, 4, 5, 6, 7, 8. So I have it as 3 times 10 to the power 8, then meter. So this is how you convert to standard form both ways. If you are moving from your right to from your left to your right, the exponent is negative. If you are moving from right to left, the exponent is positive. So you just count the position of this decimal point as it's moving on top of every number until it gets to where you have the number you want to stop. So it depends. If I say, let me make it 30, for this one now, if I say I want to make it 30, which is not ideal, but I just want to show you how flexible this thing can be. If I want to make it 30, I can say 30 times 10 to the power 7. Why? Because I stopped here. So if I come here, I say 1, 2, 3, 4, 5, 6, 7. I stopped here. That's why I have 7. This is also correct with this. This and this and this are the same thing. They're the same thing. But this is the standard way of writing it. I don't need this 0 to be here. So I move it one more step to get my 8. All right. So this is for standard forms. But, you know, prefixes. This is it. Prefix are just letters that come before the main letter to further describe a new identity. For instance, if I put milli before a quantity, it means that it is divided by 1000. divided by 1000. If I put kilo before a quantity, kilo, it means multiply by 1000. Multiply by 1000. So if I put mega before a quantity, it means multiply by 1 million, 10 to the power 6. 1 million. Okay. So I will just solve some examples. So I have on the board converting units. So if I'm told to convert 2,500 gram to kilogram, what I will do is divide by 1,000. Why? Because 1 kilogram or 1,000 gram, let me go that way. 1,000 gram make 1 kilogram. Now please know this your units. Let me just start from basic elementary science. 10 milligram make 1 centigram, right? CG. 10 centigram make 1 decigram. 10 decigram make 1 gram. 1,000 gram make 1 kilogram. 1,000 kilogram make 1 ton. So this is your baby science conversion. 10 milligram make 1 centigram. 10 centigram make 1 decigram. 10 decigram make 1 gram. 1,000 gram make 1 kilogram. 1,000 kilogram make 1 ton. Now, if you are at this point, you are told to convert to this, just divide by 1,000. So if you are at this point, let's say, for instance, you are given in decigram, multiply this 10 by this one and divide what you got by the decigram. For instance, now, if they say convert 5,000 decigram, 50,000 decigram, well, to kilogram, just divide this one by where you are is decigram, right? Decigram times this one. So 10 times 1,000. You understand? Whatever you get by the division, this, and this. So what you have is 5 kilogram. So 50,000 decigram make 5 kilogram. So what I'm trying to say now is that from this table, know where you are. Whatever you are given, if you are given in kilogram, in gram, the value you are given in gram, divide it by 1,000 to get the kilogram equivalent. If you are given in decigram, whatever you are given in decigram, divide it by the product of where you are here, this and this, divide it by the product of these two to get it in kilogram. If you are given in centigram, whatever value you are given in centigram, to convert to kilogram, divide that value by the product of this, and this, you understand, to get your value in kilogram. And if you are given in milligram, whatever you are given in milligram, divide the value of whatever you are given in milligram by the product of this, to get that. I hope it's clear. Okay, so that is how I'm trying to convert. So you say convert this to this. Just simple. I'm going to divide 2,500 by 1,000 kilogram. By 1,000 gram. See, my value, I'm giving my value in gram. To get it in kilogram, just divide it by this 1,000. That is what I've done here. So if, for instance, now this steps up to value in decigram, divide what you are having by the product of this and this to get it in this value. Okay, let me don't stress that too much. Let's go to the next one. If you need clarification, you can put it in the comment section. Okay, so after to talk about prefix, so standard form. If, for instance, we are told to write this in standard form, write this in standard form 0.00047 in standard form. SD is standard form. SF is significant figure, but we are doing standard form now. Okay, so this one is 4.7 times 10 raised to power. So this is going this way. 1, 2, 3, 4 minus 4. So this is the value. This and this are the same thing, but this is in standard form for this one. So for prefixes, if I have a cable is 5.6 kilometer, very long cable. So let us express this in meters. Express in meters. So how many meters make 1 kilometer? So I have 1,000 meters make 1 kilometer. So to express this in kilometers, in meters, I will just multiply this by this. Multiply. So by the time I multiply it, I'll be getting 5.6 times 1,000, which will give us 5,600 meters. So this is how we do it. The kilometer has turned to meter. So you need to look at significant figures. Running up to significant figure is just to start counting from the first non-zero digits. You count from the first non-zero digits. So for instance, now this one, let me put it on another. Okay, let me still put this one. 0.00047. Let me put 8 here. Oh, my word. 478. Okay. Now, if this one is in, to convert this one to two significant figure, that's to convert this particular number to two significant figure, I'm going to start to count from the first non-zero digit, that's from this one, and say 1, 2. So in significant figure, this is this one becomes 0.00047. It's supposed to be 47, but because the next one is more than 5, I'll take it as 1 and add to the 7, and becomes 48. You understand? 48. So if it is 3 significant figure, I will just say 478. That's the same thing. All right. So you see that this particular skill is necessary for this topic. So you have to go and practice your units and conversion and know how to use your standard figures very well. So I'm going to be leaving some questions on the comment section. If you have watched the video up to this point, just visit the comment section to see sample questions and sample answers, and let's spark up a conversation in the comments. I'm going to quickly summarize what we've done today. Always work in SI units. SI units means System International. Convert before calculating. I've shown us all the SI units. Secondly, let's use standard form for large and small numbers, so know how to convert it. We'll watch the video to check how to do that conversion. Then prefix notation is like a kilo for 10 raised to the power 3, and so on. We can also round up to sensible significant figures based on measurement precision. And we also know that clear units and correct notation show professionalism. Examiners reward that. So please know how to represent your quantitative expressions in clear notation, in correct units. So I hope this video has been informative for you. I'd like to thank you for viewing.